As we speak, the night sky is undergoing profound and unprecedented changes, setting the stage for a transformation that could drastically alter its appearance within just a few decades, if not sooner. These developments have sent ripples of concern through the global scientific community, particularly among astronomers who have dedicated their lives to studying the cosmos. Leading voices in the field, including renowned astrophysicist Neil deGrasse Tyson, have corroborated emerging data suggesting that Polaris, the star long cherished as the steadfast North Star, is on the brink of a significant transformation. The narrative behind this potential cosmic shift is not only intriguing but also deeply unsettling. For centuries, Polaris has been more than just a star. It has been a celestial anchor, a beacon in the night sky that has guided countless stargazers, navigators, and astronomers. Its central position in the sky, almost directly aligned with the Earth's rotational axis, has rendered it a unique and constant reference point, allowing ancient mariners to navigate the vast oceans and enabling astronomers to map the heavens with precision. However, this reliability and stability, which have defined Polaris's role in the night sky for millennia, are now under threat. The very stability that has made Polaris an indispensable tool for navigation and astronomy could soon be compromised, leading to significant changes in both our understanding of the cosmos and the practical uses we derive from it. To fully grasp the gravity of this situation, it is essential to delve into the history and characteristics of Polaris, a star that is now entering what could be its final stages. Historically revered as a guiding light, Polaris has been a symbol of consistency and dependability in a universe that is constantly in motion. Astronomers and navigators across different cultures and epochs have relied on its unwavering presence, and its loss would represent not just a scientific but also a cultural and symbolic blow. Recent findings presented by the Royal Astronomical Society in September 2023 have heightened concerns about the future of Polaris. This respected institution has published studies indicating that Polaris is on the verge of a catastrophic event, an explosion that could result in its permanent disappearance from the night sky. This revelation has sent shock waves through the astronomical community, as the implications of such an event are profound. The disappearance of Polaris would not only disrupt our night sky but could also challenge our long-held assumptions about the stability of stars and their life cycles. Before we explore the broader implications of this potential cosmic event, it is important to understand what makes Polaris so special. Also known as the North Star, Polaris occupies a unique position in the sky due to its proximity to the celestial North Pole. This alignment means that Polaris appears almost stationary in the sky, making it an invaluable point of reference for those in the Northern Hemisphere. Located in the constellation Ursa Minor, Polaris is not just any star. It is a yellow-white supergiant, a star of moderate brightness but considerable size, especially when compared to our Sun. What many may not realize is that Polaris is not a solitary star but rather a complex triple star system. The primary components of this system, Polaris AA and Polaris OB, are so close together that they appear as a single star to the naked eye. However, there is also a third companion, Polaris B, which orbits this binary pair. The gravitational forces at play within this system are intricate, shaping the orbits of the stars and influencing their behavior. These interactions directly affect the brightness of the stars and other notable characteristics, making Polaris's stability all the more remarkable and its potential instability all the more concerning. Any disruption in the delicate balance of these gravitational interactions could lead to irregular changes in the star's luminosity or their pulsation patterns. Despite our advancements in astrophysics, we still do not fully understand the precise mechanisms behind these processes. Polaris is located approximately 323 light-years from Earth, which means that the light we see today from the star was actually emitted over 3 centuries ago. This vast distance introduces a delay in our observation of any events occurring on Polaris. For instance, if Polaris were to explode today, we would not become aware of it until 323 years later. This time lag creates a significant challenge in studying and predicting the future of Polaris, as the star's current state might already be drastically different from what we can observe. The idea that Polaris could have already exploded and we are merely waiting for the light of that explosion to reach us is a haunting thought. It suggests that the star we have relied on for so long could already be gone, and we are merely witnessing the remnants of its past. This possibility is based on the scientific evidence available today, which implies that such an event is not only plausible but perhaps inevitable. Throughout history, Polaris has been more than just a navigational tool. It has been a cultural and symbolic icon. Its constancy has made it a symbol of stability in a world that is constantly changing. Across various civilizations, the North Star has been revered for its reliability, acting as a fixed point in the sky around which the heavens appear to rotate. Its role in guiding travelers both on land and at sea cannot be overstated. The star's unchanging position near the celestial North Pole has made it an essential reference point, especially for those in the Northern Hemisphere. Without Polaris, the very foundation of celestial navigation, which has been used for centuries, would be fundamentally altered. In recent years, however, Polaris has begun to exhibit behavior that deviates from what has been observed for centuries. This disturbing change in its pulsation cycle has caught the attention of astronomers worldwide, prompting a flurry of studies and analyses. Instead of following a predictable and regular pattern of dimming and brightening, Polaris has started to exhibit an erratic cycle with variations that are both unpredictable and concerning. This deviation from the norm has led scientists to believe that Polaris may be nearing the end of its life cycle. The changes observed in Polaris are consistent with those seen in other stars as they approach the final stages of their existence. The progressive increase in the time it takes for Polaris to complete a pulsation cycle, a duration that was previously stable, suggests that the interactions between the stars in the Polaris system are becoming more pronounced. These interactions, although perceived as occurring within a single entity, are likely causing significant internal changes that we do not yet fully understand. One particularly notable observation is the recent increase in the pulsation duration by approximately 4.5 seconds. While this change might seem minor, it is of great significance to astronomers, as it could indicate a fundamental shift in the internal dynamics of the star. Some scientists have cautiously proposed that these fluctuations might be due to gravitational forces between the stars in the Polaris system, which are affecting the star's atmospheric conditions and, in turn, its pulsation patterns. However, not all astronomers are convinced by this explanation. A growing number of experts believe that these changes are a sign that Polaris is on the verge of a supernova, a massive explosion that marks the end of a star's life. This suspicion is further fueled by comparisons to Betelgeuse, another prominent star located in the Orion constellation. Betelgeuse has also shown puzzling alterations in its brightness, leading to widespread speculation about its possible imminent explosion. The similarities between the behavior of Polaris and Betelgeuse have led some to draw parallels, suggesting that Polaris might be following a similar trajectory. NASA has taken a keen interest in Betelgeuse's anomalies, closely monitoring the star for signs of an impending supernova. The agency's concern is understandable, given the potential impact of such an event on our understanding of stellar evolution. However, while NASA has been vigilant in observing Betelgeuse, it has not yet issued a similar level of concern regarding Polaris. This difference in attention has raised questions within the scientific community, as both stars exhibit signs of instability that could herald significant cosmic events. Stars like Polaris undergo a long and complex journey through different stages in their evolutionary cycle. In their youth, these stars have relatively low temperatures and brightness. As they mature, they enter the main sequence phase, characterized by nuclear fusion, where they remain stable for billions of years. However, as their hydrogen fuel is eventually depleted, they enter the red giant phase, experiencing a rapid increase in temperature and brightness. This phase is marked by a dramatic surge in energy output, which ultimately leads to a catastrophic explosion, a supernova. If Polaris were to experience a supernova, the event would be nothing short of spectacular. The star would become incredibly luminous, eclipsing even the brilliance of the moon and dominating the night sky as one of the brightest objects visible to the naked eye. This luminous display could last for days, weeks, or even months, with the star undergoing drastic changes in its appearance. It could transform into a dazzling point of light or a temporary bright object, potentially exhibiting a range of colors before finally fading from view. Such an event would not only alter our perception of the constellations Ursa Major and Ursa Minor, to which Polaris belongs, but could also provide valuable insights into the life cycles of stars. Despite the potential visual spectacle, a supernova of Polaris poses no direct threat to Earth. The star's distance from our planet, coupled with its size, means that even in the event of a stellar explosion, Earth would remain unaffected. While the supernova might not be as visually spectacular as one from Betelgeuse, it would still be a significant and prolonged event visible to the naked eye and outshining many of the nearby bright stars. In conclusion, the potential changes in Polaris are a stark reminder of the dynamic and ever-changing nature of our universe. As we continue to study the star and others like it, we gain deeper insights into the processes that govern stellar evolution and the life cycles of the stars that illuminate our night sky. If you found this exploration of Polaris and its potential future fascinating, the implications of Polaris's potential transformation extend beyond the realm of astronomy and navigation. The study of such celestial phenomena provides profound insights into the fundamental processes that govern stellar evolution and the life cycle of stars. Understanding Polaris's potential shift offers a unique opportunity to observe and study a star nearing the end of its life cycle in real time, a rare occurrence given the vast distances and timescales involved in astronomical phenomena. One of the most intriguing aspects of a star like Polaris undergoing a significant change is the opportunity it presents for astronomers to refine their models of stellar evolution. The transition of a star from a stable phase to a more dynamic and unpredictable state can offer clues about the underlying physical processes that drive these transformations. For instance, detailed observations of Polaris's behavior might reveal more about the interactions between a star's core and its outer layers, which are critical to understanding how stars eventually shed their outer envelopes and reach the supernova stage. Additionally, the study of Polaris's behavior can enhance our knowledge of binary and multiple star systems. Polaris, as a member of a triple star system, provides a natural laboratory for investigating the gravitational interactions and dynamical effects in such systems. These interactions can influence not only the brightness and pulsation patterns of the stars involved, but also their overall stability and eventual evolutionary paths. By observing these effects, scientists can gain valuable insights into the complex interplay between stellar companions, which is crucial for understanding a wide range of astrophysical phenomena. Moreover, the potential disappearance of Polaris would have a ripple effect on various scientific fields. For instance, astronomers rely on the North Star as a reference point for calibrating observations and conducting astrophysical research. The loss of Polaris would necessitate adjustments in observational strategies and methodologies, potentially leading to the development of new techniques and tools. This could drive innovation in astronomical instrumentation and observational practices, as researchers seek to adapt to the changing sky and maintain accurate measurements of celestial objects. From a broader perspective, the anticipated changes in Polaris also highlight the dynamic nature of the universe itself. The cosmos is in a constant state of flux, with stars being born, evolving, and dying over timescales that span millions to billions of years. Polaris's potential transformation serves as a reminder of the ongoing processes that shape the universe and underscores the importance of continued exploration and study. It emphasizes that even seemingly stable and enduring features of the night sky are subject to change, reinforcing the need for persistent curiosity and scientific inquiry. In addition to scientific implications, the cultural and historical significance of Polaris cannot be overstated. As a symbol of guidance and stability throughout human history, its potential loss would resonate deeply with many people. The North Star has been a constant reference for travelers, explorers, and navigators for centuries. Its role in guiding voyages and journeys has been critical to the development of navigation techniques and the exploration of new frontiers. The potential disappearance of Polaris could evoke a sense of nostalgia and loss, as people reflect on the star's long-standing role in human history and its impact on our understanding of the world. Furthermore, the study of Polaris's potential transformation offers an opportunity for public engagement and education in science. The dramatic changes in the night sky could capture the public's imagination and inspire interest in astronomy and space science. Educational programs and outreach efforts could leverage this phenomenon to teach people about the nature of stars, the principles of astrophysics, and the importance of scientific observation. By connecting the scientific and cultural significance of Polaris with broader educational efforts, we can foster a deeper appreciation for the wonders of the universe and the ongoing efforts to unravel its mysteries. The potential transformation of Polaris also prompts reflection on the broader implications for our understanding of celestial navigation. For centuries, Polaris has served as a reliable reference point for navigation, enabling travelers to determine their position and course. Its potential disappearance would necessitate the development of new methods for celestial navigation and the identification of alternative reference points. This challenge would drive innovation in navigation techniques and tools, ensuring that we continue to navigate the world with precision and accuracy. In conclusion, the potential transformation of Polaris represents a profound and multifaceted phenomenon with far-reaching implications. From refining our understanding of stellar evolution and binary star systems to inspiring public interest and driving innovation in navigation techniques, the study of Polaris offers valuable insights into the nature of the universe and our place within it. As we continue to monitor and analyze the behavior of this iconic star, we gain a deeper appreciation for the dynamic and ever-changing nature of the cosmos. The story of Polaris serves as a testament to the enduring pursuit of knowledge and the excitement of exploring the mysteries of the night sky.